Hey everybody, this is your video for your 4-4 Math Excel. So again, on most of these you're going to need to use your calculator, so keep those charged. On the first one, it has a 2 by 2 matrix times x equal this, another 2 by 2 matrix. So think of it as a times x equal b, and so instead of dividing, you're really doing the inverse. So x is the inverse of a times b. So basically you just have this raised to the -1 power times this. Okay, so you just do the inverse of this one times this one equals your answer. On your next one it says your classmate is starting a new fitness program. He is planning to ride his bicycle 60 minutes every day. He burns 8 calories per minute at 11 miles per hour and 12.25 calories per minute at 15 miles per hour. How long should he bicycle at each speed to burn 650 calories? So the first part is you got to say x is going to be at a certain speed plus y at a certain speed to total up your minutes. So it's this many minutes plus this many minutes equals 60 minutes. And then you have your 8 calories, so 8 times x plus 12.25 times y equal your total calories. Now notice, and this is really important, the speeds aren't used in an equation. So the 11 and the 15 are not in an equation. So those are extra numbers in the problem. So those are your two equations you need, and then you call the x, y as 1, 1, the 8, 12.25 here. This is your variable matrix, and you put x and y there in this problem, and then this is your constant matrix, so you put your 60 and 650. So now to do this, you keep your x, y where it is, take this and do your inverse to it, then times this. When you do that, you get 20, 40 in my case with these numbers. So that means 20 minutes at the 11 miles per hour and 40 minutes at the 15 miles per hour. So again, I took this and I wrote it here. I did to the -1 times your number matrix and you get your answer. So this is 20 minutes at 11 miles per hour and 40 minutes at 15 miles per hour. Okay, on your next one, it says write the following system as a matrix equation. Identify the coefficient matrix, which are the numbers in front, the variable matrix, which in your case, or at least in my case, is A and B. That's what our answer is going to be. And then the constant matrix. And see, basically just look at this. You don't really need to know like all of this, A, B, C, D, X, Y, E, F. The main thing is it's 8, 6, 1, 1, 8, 6, 1, 1. And then we put A and B because those are the letters they use, and then they have 0, 9. So in almost every problem you do your matrix from left to right. The only one that we didn't was that coding matrix that you had to do your A is 1, B is 2, C is 3. So some of y'all, again, will see that on your review. So again, most of the time you just have a horizontal part. For the next one, you have these equations, and I decided to test something and it works. So this is for your benefit. You can either do your inverse like we did before, or you can do RREF. It gives you the exact same answer. So if you do RREF of all of this, you get this, and so then this part's your answer. So you get -4 and -3. So remember, that's menu, matrix, 5, reduced row, echelon form. Because they just wanted your X and Y answer, and so you could use ref like we did, like on 4.2, I think. On this one, what they want is for you to interpret this. You have X, Y, Z, so you put 1, 1, 1, 7, 8, and then there's nothing here. My spacing wasn't perfect, but there's no Z, so you put a 0 there. Just like on this one, there's no X, so you put a 0 there. And then you're 1 and -6. So make sure you type in your numbers, and then you have your X, Y, Z, and then you have your constants. So again, to solve it, you keep your X, Y, Z where it is. You put this exact same thing here to the -1 power, and then times this one, and that gives you your answer. Now you have one very similar to it, but I lined it up a little bit better this time. There's no x's, so you put 0, then 13, then 2, 5, then 2, then 1, because if there's no number, you put 1, and then equal to 14. And this one is x minus y, so 1 minus 1. There's no z in this case, so you put a 0 there. Then you put your x, y, z, and then you put your 7, 14, 2. So once you have that, then this goes here to the -1 power times this. And again, you get your answer. So that's with using the steps for the inverse. Also, remember, you could have just said ref 0, 13, 2, 5, 2, 1, 1, -1, 0. I'm actually going to type it out both ways just so you can say, oh, I know for sure it works. So menu 7, 1, 1, you're doing a 3 by 3 matrix. You have 0, 13, 2, 5, 2, 1, 1, -1, 0. Now that matrix to the -1 power, so we do this up arrow thing, this caret, and then you do -1. So we're taking that matrix times your other one. So this is a 3 by 2. I'm sorry, 3 by 1. 3 by 1. And you put your 7, 14, and 2 here. So there's where you get your 3, 1, -3. Okay, now as I mentioned, I discovered that if you do ref of this, which is your reduced row echelon form, you would get the exact same answer. And again, this is a 3 by 3. And so you get your 0, 13, 2, 5, 2, 1, 1, -1, 0. So when you do your ref, doing that off the top of my head, and I've left off the 7, 14, 2. So that's probably a good example of a mistake. So I really want a 3 by 4. 0, 13, 2. Okay, let me put in the other number, 7, 14, 2. So this is a 3 by 4. Okay, so 7 there, then 5, 2, 1, 14, 1, -1, 0, 2. Okay, so when I did that, you can see on the far right I get 3, 1, -3, just like I got 3, 1, -3 here. So either method works. All right, on your next one, You have this matrix times your xy equal this matrix. And so I just copied this down, put this over here with the -1 power, and then times this, just multiply it, and you get your answer. Okay, then on this one, it's a word problem. A caterer combines ingredients to make now I don't speak Spanish, paella, or whatever you want to call it, Paella. It's a Spanish fiesta dish. It weighs 27 pounds, costs $51.95, and supplies 1,620 grams of protein. So you have this table, you have your food, and it's going to be either chicken, rice, or shellfish. You have your cost per pound, which I won't read, and your protein per pound. So when we're doing this one, X is going to be your pounds of chicken, Y for rice, and Z for shellfish. Okay, so first thing is you want to write a system of 3 equations. So the first thing is called the total weight equation. So it's like how much X plus how much Y plus how much Z equal 27. So that's your weight equation. The next one is going to be this, which is your money equation or cost equation. And you set it equal to your total cost, $51.95. And then for this one, you have your protein equation, 120, 30, 30, and then your total. So that's your protein equation. So that's your answer to part A. Then for part B, they want you to solve it. And so I just took the numbers that I was expecting, put it to the -1 power, times this, and that gave me 9, 13, and 5 in my case. So that means 9 pounds of chicken, 13 pounds of rice, and 5 pounds of shellfish. Then for extra practice A, it says solve AX equal B for X, and so X is A -1 times B. Again, it's not B divided by A. So it's basically not division. You just take that exact matrix, raise it to the -1 power, and then times your numbers. Then you get your answer. And then on this one, it's extra practice B. And this is where, when I was working through these, I actually discovered you could do RREF of this and get your answer. So X is 6, Y is 5. Or you could do this to the -1 times this, and you get 6, 5. So again, if it's asking for X and Y, or even if it's asking for X, Y, and Z, you can do it either through RREF or through your inverse. Okay, the next ones are for Algebra 2 honors. And everybody else, you could see this possibly on your review for your tests. It says solve the system using matrices, use Gaussian elimination with back substitution or Gauss-Jordan elimination. Now that sounds really weird. Why don't we just do it like we always do? So we were given this equation, and so you just put 1, 1, -1, 12, and so forth. RREF of that, and then you get your answer. And so like this side is your answer, and so you get 8, -1, 5. So again, just use RREF, reduced row echelon form, and you get it. The next 3 have the same instructions. And then this one is the same thing, except for it had a 4x5 matrix. They had 3W minus 2X plus 3Y minus Z equal 9. And then they had others. I just ended up starting writing the numbers, like I would say for the matrix, 3, -2, 3, -1, and then these. Do RREF. And then once you do RREF, you get this. And so when I did it with my diagonal ones with all these zeros, This was my answer. So I got 3, 3, 3, 3. The next one, now this one is pretty interesting because I didn't know you could work this type problem with matrices. Find the quadratic function ax squared plus bx plus c for which you have this ordered pair. Well, it says f of 1 equal 3. If f of 1 equal 3, you know f of x equal y. So it's basically 1, 3. So this represents 1, 3. This f of negative 2 equal 27. That's this ordered pair. And then this one is 2, 31. So your inside is your x and your outside is your y. So what they're doing is saying since f of 1 equal 3, then use this equation and plug in 1 for x, because that's what we wanted. So a times 1 squared plus b times 1 plus c. Then you set it equal to the y answer, which was 3. And so that basically gives you a plus b plus c equal 3. Now, the other one, so that was your first ordered pair, basically. For your next ordered pair, you use negative 2 for x. So a times negative 2 squared. Make sure when you're doing that, you put parentheses around it, or just do it mentally and think 4. And so you have 4a minus 2b plus c equal 27. Then for your third one, we have xy is 231. So you plug in 2 for your x's and then 31 for your y. So then with the a plus b plus c equal 3, we just put 1, 1, 1, 3. And then this one we put our 4, negative 2, 1, 27. 4, 2, 1, 31. So when you do our ref of that, you get this, and so 9, 1, negative 7 is your answer. And so what that indicates is it would be 9x squared plus x minus 7. So it is possible to do your question that way. What I was expecting was having to do quadratic regression with using ordered pairs. But I won't show that because we were able to do it this way. Then the next one, the hardest part about this one is you need to have all your letters on one side and your numbers on the other. X plus 3y equals z plus 5, so that means x plus 3y minus z equal 5. And then this one, you got to move over your y, move over your z. So x minus y plus z equals 7. And this one, it's already right. Then I just do R ref of those, and I get my answer. So 513 is my answer. That's your ordered triple. Then on the last one, it says the nutritional content per ounce of 3 foods is in a table. If a meal consisting of the 3 foods allows exactly 900 calories, 200 grams of protein, and 850 milligrams of vitamin C, how many ounces of each food should be used? So here's your table that was in Math Excel. And so what you do is you have a calorie equation, so that uses these numbers: 100 for coefficient for A, 200 for B, 600 for C. Then you go back to this and you see your 900, so you put it there. Then you do your 11, 9, 4, and then you take your 24, put that there, and then this one, same way. So then you do your R ref of this, and in my case I got all ones, which meant 1 ounce, 1 ounce, 1 ounce. Now, you're not always going to get that, because I did a similar question just to try it, and sometimes you get different ounces. You could have 4 ounces, 16 ounces, whatever. The most important part is make your equations from the vertical columns. So your calories equal that, your protein equal that, and your vitamin C equal that. So that's how you work it. Let me know if you have any questions.